What's up, everyone? It's Noah. Welcome back to Python. Today's video we'll be talking about imported math. So, it's kind of a continuation of last video, except these are built-in functions that Python allows us to use instead of just like basic operators. So as always, open up your idle. You already know what I'm allowed to say. File, new file, and then you get to where you can write all of our code. So, for math functions in Python, it requires us to do something that we haven't had to do before. So there's a syntax thing called import in Python, and there's a whole bunch of things you can import. You can import like time, math, and like a whole bunch of other stuff. But for chances are the only one you'll ever use, and the only one I think we'll use, no, we'll use another one. Yeah, but basically what we'll be using today is something called import and then math. So to be allowed to use any of these math operators that I'm about to show you, you must import math. If you try to do any of them without typing this import math, it just won't work. And it's nothing crazy. This is just something you have to remember. There's no like catch to it or anything. It's just remember, just import math. Most times when I make a new Python file, if I'm just like coding on my own or something like that, by default, I just import math. I'm like, oh, I'm probably gonna end up using it at some point or another. So just go ahead, import it, get it out of the way. So the first thing I'm going to show you guys is what I was telling you about last time with flooring. So if we have a is equal to 10.4. So I told you last time if you do like the double slash, you get floor division, or you can just do it this way. I like to avoid floor division as much as possible for some reason. But let's say if this is like a product that we or an answer that we got for something, we got a is equal to 10.4, or if it's just a number. So if we say something called math dot floor of a. So floor, what it does is it takes the number 10, and since it's floor, it puts it to the lowest whole number, the closest lowest whole number. So in 10.4 case, it's 10, because it just chops this and just goes down for floor. So for Python, doing this isn't enough. Like if we do math.floor of a and then try to print a, it's still just gonna be 10.4. In order to see the change, we either have to set it back equal to a, which is kind of weird. I just prefer to make a new variable and set it equal to that. So if we print b, you get 10. So yeah, so floor, basically think of it this way: just chop that guy off and just get rid of him. But if obviously we'll show that's negative 10.4, now you're going to think the opposite. So I'll get rid of this 10. So obviously a negative, it'd be backwards. It'd go to negative 11. So yeah, basically it just goes to the lowest but closest whole number for flooring. So yeah, that's flooring. The next one is the exact opposite. Say C is equal to 10.4 again. They'll stay consistent with my numbers. And then there's something called math.ceil. Basically, it's ceiling. So we have this 10.4, and the ceiling of it would be the highest whole number that's within range. I don't know how you want to describe it, but like the highest, it's like rounding up to the next thing, no matter what this thing is. If there's something in here, if you're sealing it, it's going up to 11. So if you do ceil of C, and once again, to actually show the difference, we have to set equal to something. And if we print E, we should get 11. And then I'll show you guys this. This works for both of them, but I'll just show it for one. So if, just like the last video, you can do operations right in here. So I'll say math.floor. I just wanted to show you guys 11, for example. So it's already a whole number, and it's already the lowest or highest it could be. So it's just going to be the same. And then I'll just show you with a float, and you can see it just goes down to a normal thing. So math.floor, math.ceiling, taking floats like this, or not, or just integers like I showed you before, but they always return an integer. And you're allowed to put in integers, but then obviously it's just going to stay the same. Math that floor, math that ceiling of 11 is always 11. So another one that we have, something called math.pi. So this is a syntax for math.pi, just like the other ones, math.floor. But instead of having this like parentheses like the other ones have, it's just something as is. So pi is obviously like the 3.14159, whatever like that. That's all this is. So you can just use it just like any old number. Just like literally look at math.pi and just take it as any other number. So we can say a is equal to math. I can't use a. I already used it. A1 is equal to math.pi plus 5. We print that, you get your whole thing. So yeah, math.pi, it's literally just treat it as just like another number, and then it has all the same functionalities of every other number. You just have to obviously remember to import math, and then just say math.pi, and there you go. You can use it for absolutely anything that you want. All right. So our last one that I'll be going over. So these ones are really just like the big ones. These are the only ones I've ever used. And normally, if I do need to use like something else like random, I'll look it up online or whatnot. But these are the only four that I've ever used, and I honestly I couldn't see uses for other ones, at least for me. But I know there's stuff out there. So the next one is math dot squirt. So this is square root. So in the last video we showed you like exponential, like 2 raised to something. And then this one's just basic, just square root. So these ones work the same as ceiling and floor. It has the parentheses, and you got to put something inside of it, the parentheses, for it to work. It's not like math.pi where you can just do something, obviously, because math.pi is just a number. So we'll set s equal to 64, and then we'll say q is equal to math dot square root of s. So then if we print s, or q, excuse me, we should be getting math that square root of s, or the square root of 64, which is 8.0. And notice that it comes out as a float. So just like the float division from last video, when you square root something, it always comes out as a float. Even though it's the square root of 64 is just 8, it comes out as a float, 8.0. Once again, I'm not sure why. It's just what it does. So, now, I'll just give you guys a short little quiz. Have a nice short video. Let's see. What do we want to do? So, what is the floor of, we'll say, 15.9? What is the ceiling of, we'll say, 20.1? And we'll just say 20.0. Fair enough. Math.pi, you can't really do anything with, just a number. And then what is the, we'll say math that's, just so you guys are aware. And then obviously same thing with these ones up here. Math dot of 100. So take a minute, pause the video, answer these questions, and I'll get back to you guys in a little bit about it. All right. Plenty of time to do it. Let's get into it. So, what is the floor of 15.9? So we know that floor for positive numbers, it just takes the number and it puts it to the lowest whole number that it could be. So in this person's case, we got 15.9. The floor of 15.9, the math dot floor, if you want to be specific, is just 15. And then our next question we got, what is the ceiling of 20.1 and 20.0? So we have 20.1. So now the next highest whole number that 20.1 could be is 21. That's the next highest one it is. So then the first part is 21. And then what's the ceiling of 20? It's just, or 20.0, excuse me. It's just 20. So you have 21 and then 20. for this middle one. And then what is the math dot square root of 100? So notice, might be tempted to say 10 because the square root of 100 is 10. Excuse me, but remember that when using square root, they come back as floats. So we have 10.0. And a bonus question, don't look at the screen. What do you always have to remember to do when using all these functions? At the very top of something, at the very top of your page, you got to do something in order to use all of these math functions. Do you remember what it is? If you said import math, you'd be correct. So the bonus point for you. So you could have gotten a 4 out of 3 instead of a 3 out of 3. Or you could have got 3 out of 3 if you got something wrong. But yeah. Yep, so in our next video, we'll be going over if statements. That's it for this video. That's all I wanted to cover. Those are the 4 basic ones that you guys will be using more than likely than any other ones. And yeah, so next video, excuse me, I'll be going over if statements and else statements, how they work and whatnot. And yeah, that's all I got for this video. Thank you guys for watching. And as always, leave a comment, join the Discord if you guys have any questions or anything. I'll be sure to answer them. See ya.